Welcome to this drawing and design lesson. My name is Mr. Peter Kamwelu. I teach drawing and design at the Moi Forces Academy. Today we are learning basic construction. We expect that by the end of this lesson we should have learned how to divide a line into given parts, to divide a line into a given ratio of parts, to construct a triangle to a given ratio, and then to construct an isosceles triangle and an equilateral triangle given specific conditions. Now, there are some prerequisite knowledge that we already know. We already know, for example, how to bisect a line. Given any length of lines, we can bisect by getting two intersecting arcs on the upper and the lower side of the line, and then drawing a line perpendicular to the original line, such that our original line AB is now divided into two. The process of dividing a line into two is called bisecting a line. Bisecting a line. Also, we know that given two intersecting lines, the angle formed at the point of intersection between the two lines, say that point is A, such that our line is AB and the other one is AC, we can be able to bisect that angle as follows. Make two arcs from the point of intersection A and make intersecting arcs so that we draw the intersecting line called the angle bisector line, and the two angles are equal, so that this is theta, that's theta degrees. So also, we do know to construct a few angles. We can construct an angle of 45 degrees, an angle of 60 degrees, and an angle of 90 degrees, and they are supplementaries and they are complementaries. So from a point A on a line AB, it is possible to erect a perpendicular line by using the following method. Draw an arc that way and make two steps equal to the original radius. Bisect the difference and the line that you draw joining the intersecting arc and the point A is the line that is perpendicular to the original line AB. If from the original line you join it through with the first arc, the angle formed is equal to 60 degrees. So that angle is 60 degrees. The angle on the original side and also the reverse side is still perpendicular, and drawing a square to join the two indicates that the angle formed there is 90 degrees. We can further draw angles of 30 degrees from using the same radius, same original radius, and drawing it from the point where that arc met the perpendicular line. We can divide that line, that angle of 90 degrees into angles of 30 degrees. Further successive bisection should be able to get angles like 7 and 15 degrees, 7.5 degrees, 67.5 degrees, as you continuously do successive bisections of these angles. For the angle of 45 degrees, again, let's draw our line. AB, draw the same arc and proceed to draw the angle of 90 degrees, just like in the previous example. If you bisect the angle of 90 degrees, then the angle formed is 45 degrees. And the angles that are complementary to it at 45 degrees are also 45. But subsequent dissections or subsequent dissection of the angle 45, you'll get us 22.5 degrees. It's 2.5 degrees. And of course, if you are 22.5 degrees, you can be able to get 67.5 degrees from 45. If you are 22.5 degrees from to 45, you can get an angle of 67 degrees. If you went to the reverse side of these angles, you can be able to get the supplementary angles to 22.5 degrees, 45 degrees, that is 195, etc., etc. Now, for today's lesson, we are targeting that we divide a line into a given parts, and also we divide the same line into a given ratio of sides. Now, learners, dividing a line a given line AB into a number of parts, say 7 parts, is essential because it will assist us in drawing all forms of rock side as we do mathematics, and also for other divisions, especially in construction work in life. It is done by drawing the original line to the length. In this case, we can give our line a length that is odd, say 93, then draw another line from the start of point A, and that angle should not be so acute. It should be around the range of 90 degrees. Step off the number of parts that you want to divide. In this case, we have said 7. Make your arc reasonable. 1, 2, 3, 4, 5, 6, 7. Join. Go to number them. 1, 2, 3, 4, 5, 6, 7. Join number 7 with B, and we proceed to subsequently draw parallel lines on each of the segments previously formed, such that all lines are parallel. Please note that all these lines are parallel and the divisions are equal. So these are equal divisions. We managed to divide our original line AB into the number of parts that we want. Now, if that our assignment was to divide that line into a given ratio of parts, say 2 to 3 to 4, now if we are given the same line and our assignment here, line AB, is we divide it into a given ratio of parts. And in this case, our ratio is 2 to 3 to 4. 2 to 3 to 4. So the first thing that we do is to add the number of the parts, that is 2 plus 3 plus 4, so that we get that the total divisions are going to be equal to 9. Then proceed just like before and divide our line into 9 equal parts. 9 equal parts. So again we make the same marks, only that this time they are 9. Four, 5, 6, 7, 8, 9. We always try to make our sizes of the arcs to be reasonable, not too small, not too large. This should be fun. Again, learners should ensure that the technique of sliding lines so that they are parallel is practiced regularly, because you find it useful even when you are doing mathematics, especially the area of linear programming, as you are looking for such lines. Good. So our relations are again 1, 2, 3, 4, 5, 6, 7, 8, and 9 being the total. So our relation was to divide our line into 2, then 3, then 4. It's good practice to just rightly outline the sections or the length at which your proportions are, so that this one is two, 3, and 4. And that should complete our task for proportional division of a line, or dividing a line into a given ratio of parts. The next task is, can we then be able to draw a triangle if the sizes of the length are given into a similar ratio? Whereas, where you're given a perimeter, say 170, and then you're told the sides are in the ratio 2 to 3 to 4. The same concepts, learners, will apply. The first thing that you do is that our line AB now has specific measurements. In this case, it is 170. So that one becomes the perimeter of our triangle. This is AB now is equal to the perimeter of that triangle. Once again, draw our line, we said that the angle should not be so acute, neither should it also go so much towards being a right angle. So divide the space into 9 equal parts, because 2 to 3 to 4 is a total of 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Learners are advised to number them that way as a matter of precaution, because occasionally you find you have made one arc more or less, and then when you join, you find that the divisions are not to the desired proportions. So once again, point number 9 to join B there, and then we proceed to draw parallel lines to the line 9 . Good, we have made the divisions just like we did in the original question, 2 to 3 to 4. Then again, it's a matter of good practice. Ensure there is a slight outline at the point that you want to divide, so that it's 2 to 3 to 4. Then you can see that the middle one becomes then B and C, and you can look for now point A by just drawing this arc there, and from C to the original A here, we draw that arc. So if we continue to complete that triangle, let's use a different color so that we can highlight. And we say that our perimeter and for the purposes of avoidance of ambiguity, let's have this vertex once again to be X, Y, and Z, so that this one is 4, this one is 3 parts, and this one is 2 parts. Our triangle, whose original perimeter was 170 millimeters, has now been divided into the ratios of 2 to 3 to 4. So 170. All measurements as we learn learners are in millimeters unless specified otherwise. Now, the second construction that we are to do this morning is construct isosceles triangle given the base and also given the perpendicular height. So the first one is an equilateral triangle. An equilateral triangle. Given a side, for this case, we are given side AB, or let's say side PQ, and the length of that PQ is 70 millimeters. Drawing an equilateral triangle is a simple exercise. Set your compass at the original PQ 70 millimeters and get intersecting arcs from both center P and center Q. And when the intersecting arcs meet, if you join that one to the original point P, the angle formed is 60 degrees from either side points, both points P and Q, so that R is also 60 degrees, and the three sides PQ and also PR and QR are equal. We mark that by showing just a small mark there to indicate that the 3 points are equal. An equilateral triangle means equal lines and also equal angles. So it can also be called equiangular, just like it's called an equilateral. The next triangle that we construct is an isosceles triangle. Isosceles triangle. An isosceles triangle has two equal base angles. And therefore, example, if two base angles are equal, A, B, then also two sides are equal. So in this case, we are going to say given the side and also the perpendicular height. Isosceles. Isosceles triangle. If you are given the side, the length of AB, say 60, and the vertical height and a vertical height of 55 millimeters. The procedure for drawing an isosceles triangle is as follows. Bisect this line, the original line AB, so that you have those two arcs. Bisect that line. Draw the bisector on the line perpendicular to the original line AB. Along the bisector, mark length of 55 millimeters. 55 millimeters. To get our point C. Now join AC and BC. You'll notice that with the two angles equal and two sides equal, this one is isosceles triangle. If the two sides equal, then also two angles are equal. Again, we said 55 degrees. Good. And that has been basic construction. Today we've learned how to construct angles of 45 degrees, angles of 60 degrees. They are complementary and also they are supplement angles. We have learned how to divide a line into a given part. We have also learned how to divide that line into a given ratio of parts. We have drawn a triangle with given the perimeter and also the ratio of the sides. We have learned how to construct both the equilateral triangle and isosceles triangle. In the next lesson, we are going further to explore and construct triangles of the isosceles triangles, given angles, these angles, and also other conditions. We are also going to draw scaling triangles and right angles triangle. Thank you so much, learners. Until next time, goodbye.